All right, so this is problem 16A. 16A is an ICE problem, and we're going to use it. And where you have this set up, it's not perfect, but I figure it's closest that you have to actually doing it on paper at home. So we use an ICE chart to get a value, something for K with X's, etc. And, X times blah, 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 X, etc. And now we need to find X. And so the whole point of 16A is to be able to use two ways to do it. One is with the assumption, and the other is with the quadratic equation. Now, in some problems, you can do both. In some problems, you can't do the assumption, so you have to use quadratic equation. And in some, you can't use the quadratic equation, so you have to use the assumption. Okay? The whole point of this problem is we're going to do it both ways, and we're going to show that we get similar answers. Okay? Not exact, because this is an assumption here, but similar answers. Okay, so let's start off. The first part is the same. We're going to start off by doing the assumption. Okay, so the first thing we're going to do is we're going to go ahead and make our ICE chart. So we have I, C, E. Notice we have aqueous, 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 liquid, so I don't need that. Okay, sometimes I squiggle it out, sometimes I put an X. Okay, so what are my initial concentrations? If I look at the problem, it says it has 2 molar NH3. It doesn't mention anything else. So that means I must have nothing of anything else. By the way, it's aqueous, so that means I have a lot of liquid water. All right, so I start off with my I, then I go ahead and I put these values in for my Q. So Q is always going to be products over reactants. So NH3 over NH4 plus and OH minus. So I plug these in, I get 2 over 0 times 0. So that's going to give me something that on my calculator says undefined, but we say that's infinite. All right, so now I compare my Q and my K. Well, my K is big, but infinity is greater. So that means if I go from Q to K, I'm going to shift towards the left. So what does that mean? I'm going to get more reactant and less product. Okay? All of these are 1, 1, 1, so I just have plus X and minus X. All right, so at equilibrium, I'm going to get 0 plus X, or X, 0 plus X, X, and I'm going to get 2 minus X for this. All right, so I started with I, Q, then I figured out the shift, plugged in for C, then E, and now I can go ahead and I can use this same equation, but now I'm at equilibrium. Okay, and I say that this is equal to 5,000. Let's see, this is 2 minus X over X squared equals 5,000. At this point is where I have those two parts, right? I can either use the assumption or I can use the quadratic equation. Notice in this case, my Q, so I can do assumption or I can use quadratic. Notice that in this case, my Q is equal to infinity, my K is equal to 5,000. Both these are really big, so that means X is small. And so if X is small, I can make this assumption. All right, let's do that. We'll come back to this page later, but let's go ahead and make that assumption. All right, so we just said that 2 minus x over x squared equals 5,000. We're going to do an assumption here. Okay, so if that's the case, I can go ahead and I can look at this and I can say, all right, if x is small, that means that 2 minus x, I'm just going to say is 2. So that would be 2 over x squared equals 5,000, or 2 equals 5,000 over x squared. X squared equals 2 over 5,000. I'm just rearranging this, getting rid of this, so dividing by it. And I just flipped them just because it's nice and easy. So x equals square root of 2 over 5,000. All right, so I plug that into my calculator. 2 divided by 5,000. Do the square root of this, and that means that x is 0.2. All right, so now that I know my x, I can go ahead and let's add that to here. I just found that x is equal to 0.02. Let me make sure this is showing up. All right, so now I go ahead and I come back, and if x is equal to 0.02, that would give me that, well, let's just do it here. NH4 plus equals 0.02. OH minus equals 0.02. And NH3 is equal to 2 minus 0.02, or 1.98. Notice I start off with 3 sig figs, so let's give these all 3 sig figs. And these are my answers. What do I do next? Well, what I do next is I check my work. So I can check my work in 2 ways. First, I make sure that if I plug these in back in for k, I'll get my values. So remember, k is equal to NH3 over NH4 plus times OH minus. So that would be 1.98 over 0.02 times 0.02. And that's going to be 49.50. If I notice, I start off with 5,000. I ended up with 49.50. That's good. Why are they different? They're different because I had to make that assumption. The other thing I should check is I should check assumption. Now remember, in checking assumption, what I do is I say my percent off is equal to my assumption minus actual over actual. And now sometimes I do it reverse. It doesn't matter because it has to be, what's the word for this? Absolute value, right? So I just make it positive. All right, so my assumption was right up here. Oops, I assumed it here. I assumed x is small, so 2 minus x equals 2. So I assumed that it was 2. In reality, it was 1.98. That's going to get me 1.01%. So that's less than 5%. So that means it's a valid assumption. Okay, oops, I kind of ran over. All right, so that is when we did an assumption. Let's go ahead and do it with the quadratic equation. Now with the quadratic equation, what I do is I basically take this and I have to rearrange. All right, so I'm going to use the quadratic. 2 minus x over x squared equals 5,000. And I want to solve for x. All right, now remember to use the quadratic equation. What I want to do is I need to get it where it's a x squared plus bx plus c equals 0. So I need to rearrange this to get to this. Well, let's go ahead and show how to do that. All right, so the first thing I do is I move this over here, so that's 2 minus x equals 5,000 x squared. Then I move these over here, so that's going to get me 5,000 x squared plus x minus 2. It's very easy to mess up somewhere along the line, and that's going to leave me with 0. All right, I'm going to just flip this. I just like to have it look as much like what I started or what my goal is as possible. Sorry. 5,000 x squared plus x minus 2 equals 0. So in that case, my a equals 5,000, my b equals 1, and my c equals negative 2. And now I'm going to go ahead and I'm going to plug these all in to my quadratic equation, which says that x equals negative b plus or minus b squared minus 4ac over some value, 2a. All right, I always go ahead and I read it off the screen because I always mess it up, and on a normal test I would give you this equation so you know what it is. All right, so now I plug all these in, so that's negative 1 plus or minus 1 squared minus 4 times 5,000 times negative 2. And then on the bottom, I'd have 2 times 5,000. Okay, that's going to get me negative 1 plus or minus. See, this is 1 minus this number here. 1 minus 40,000 over 10,000. Okay. This is going to get me negative 1 plus or minus the square root of, notice, negative and negative, this becomes positive. All right, that's a big deal because you can't take the square root of a negative. All right, sorry about that. Negative times negative, this becomes positive. All right, over 10,000. All right, the square root of 40,001 is 200.0025, or just 200. This will get me negative 1 plus or minus 200 over 10,000. This will be either negative 1 plus 200 over 10,000 or negative 1 minus 200 over 10,000. Okay. This gets me 199 over 10,000. That gets me 0.0199 or negative 0.0201. All right, notice this one's negative. Typically, if it comes out negative, that means it's the wrong one. But what we have to do is we need to plug it back in order to determine it. So we get these two values. Let's go back. Sorry, let me think of how to do it. Okay, so from quad, we got that x equals 0.0199 or negative 0.0201. So I need to use both of these in here to see. All right, so for NH4 plus, that means it's either 0.0199 or negative 0.0201. Well, that right off the bat tells me it's not this value because I can't have a negative concentration. All right, so that means that's my molarity. For OH minus, my molarity is the same, it's just X. And for NH3, it's going to be 2 minus this 0.0199, so that's going to get me 1.98 molar. So there are my three values. Okay, so on the left here, this is if I use the assumption. This is if I use the quadratic. Notice I get 0.02, here I get 0.0199. 0.02, 0.0199. Very close. 1.98, 1.98. We get the same value. Let's just go ahead and check our work. 1.98 over 0.0199 times 0.0199. That's going to get me 4,999.9, right? So that's very close to what I started with. All right, so what this shows me is that in this case, I did assumption, or I could do assumption or quadratic. And in this case, they give similar results. In some cases, you can't do assumption. So you have to do the quadratic, which is more of a pain. It took an entire sheet to do. And in some, you can't do quadratic, so you have to do the assumption. Typically, if you can do the assumption, do the assumption. It's a lot quicker. All right, let's put this up on the screen so that way you can see it if this didn't turn out that well. All right, so we start off with an ice chart. Then we went ahead and we had, so this the ice chart. We looked at the shift, right? So Q was 1,000, or infinity, K was 5,000, so it's a small change. So that meant that it shifted towards the left, okay? And then I found out my K down here. Right here. And then I had to do two ways to find X, the easy way or the hard way. So this is using that assumption. Remember, if you do the assumption, you have to check your work, right? It's actually a very small deviation, so it's fine. Or we can find X the hard way with the quadratic equation, okay? If you do the quadratic equation, you'll get two answers for X. You need to plug them both in, and one should give you values that aren't possible, right? Negative concentrations. And that means the other one is the right value. All right, so that is video problem 16A. We'll move on to video problem 16B.